Well, now we get to move on to Chapter 9. This will be a little more different from the chapters 8 and 12 that we just finished. We're going to work on quadratic functions. We'll bring in factoring a little bit, but most of this will be different from what we've been doing. So maybe that's exciting or not exciting for you, depending on how you felt about the last two chapters. So 9.1, we're going to identify quadratic function, or identifying quadratic functions. We're going to learn some characteristics of them. So you can put your date there, and we will get started. So a quadratic graph, if you have not seen one before, this is what a quadratic graph looks like. Instead of drawing your straight linear lines that we've been working on in all of our graphing, now we're going to have graphs that look like this. This is called a parabola. Maybe I'll write that down here. It's a parabola. It's a U-shaped graph. Every single parabola will have a vertex. The vertex is going to be either the highest or the lowest point. Often it's kind of our starting point when we graph these. So the vertex is in the center, and then the highest or lowest. It's an ordered pair. Every parabola will also have an axis of symmetry. If you notice, this graph is symmetrical. The left side is a mirror image of the right side. So you can cut it in half, and that line down the center is called an axis of symmetry. All of our equations for quadratic functions look the same. This is standard form, y equals ax squared plus bx plus c. So this will look like all those trinomials we've worked on factoring. Anything that is raised to the second power, and that's your highest exponent, is a quadratic function, and the graph will look like this over here, some parabola. Now this parabola could be anywhere on the graph. It could be opening down versus opening up, so it would look upside down from this. So we'll see what all these look like. So the a value again, we have a function looks like this, y equals ax squared plus bx plus c. So that a value that's in front of the x squared tells us a few things about our graph. If the a value is greater than 0, which means it's a positive number, that means that our graph is going to open up. The parabola is going to look something like this. And it also tells you that you have a minimum value. And we'll talk some more about this, but that means your graph has a lowest point. That's going to be where the vertex is at. That's the lowest point on the graph. If a is less than 0, that means that the graph opens down. So it's going to look maybe something like this. And it has a maximum value. So if you look at the graph, it's going down forever in both directions, but it will not go higher than this point. So that's the highest that it is, giving us a maximum value. So our a value can tell us two things about our graph, which is pretty helpful. All right, so without even seeing the graph, can we tell if the equation or if the function opens up or down? So what we want to do, if we're given an equation like this, we want to put this into standard form. You want y on the left side of your equal sign and everything else on the right. So that tells me this 5x squared has to go to the other side. So if you remember how we move terms around within an equation, it's just addition or subtraction. Because it's a positive 5x squared, we're going to subtract it from both sides, leaving us with y equals. Now, if you notice, we've got a negative 5x squared, a 2x, and a 1. None of those are like terms, so we just want to write them in descending order of our exponents. So we're going to start with our highest exponent, negative 5x squared, plus 2x plus 1. So now that we see our equation in standard form, you want to look at what the a value is. Remember, a is the number in front of the x squared. So in this case, a equals negative 5. Because that's a negative 5, that's going to tell us two things about our graph. First, it's going to open down, so it's going to look something like this. So it opens down. Well, actually, that's all they asked us to answer. It opens down, so we've got that answered. But we also can tell that because it opens down, you can see that you've got a highest point on your graph up here. So that means that it has a maximum. And we'll talk about how to find what the maximum value is. All right, so it looks like we're going to talk about the maximum or minimum value on this graph. So, not do these graphs, I erased a couple. Does this graph, pretend that's singular, have a minimum or maximum value? And then how can we tell what it is? Well, first, up above, I kind of skipped over that. Is the A value greater than 0 or less than 0 if you look at the graph? Easy way to tell is it's opening up. If it's opening up, then that means that our A value is positive, making it greater than 0. All right, so does it have a minimum or maximum value? So you want to go to, these graphs should have an arrows on both ends. That means that it's continuing forever, in both directions. It's going to continue forever up here, forever this way. So it doesn't have a maximum value. There's not a highest point that it reaches and does not go above because it continues to go higher and higher and higher. It does, however, have a lowest point, and we can see right here there's nothing below this lowest point. So this graph has a minimum value, and how do we tell what the minimum is? Well, remember on the first slide we talked about a vertex. The vertex value is going to be this point on your graph, and we can figure out what it is. The vertex is the ordered pair. We go over 1 and down 3. That's our vertex, 1, -3. And the maximum minimum values, it doesn't have to do with how far to the right or how far to the left we go. So the 1, even though that x value, even though it's part of our vertex, it doesn't help us out with maximum or minimum, because the idea of maximum, can't even say this. The idea of maximum or minimum is how high is the graph or how low is the graph. And anytime we're talking up or down directions in a graph, that is the y value. So for your maximum or your minimum, you need to know what the vertex is, but it's the y value that we care about. So not a max. This one, the minimum value is equal to -3. So it's just a number, but that number will always be the y value of your vertex. So maximum or minimum, if you want to just make a note, it's the y value of the vertex every single time. All right, domain. Domain and range, we've probably discussed before, haven't done a ton with. So with these graphs, we're going to talk about the domains. Domain is all possible x values of the function. Domain is your input. Range is the output, which is all your possible y values. So if we can figure out the domain and range just by looking at the graphs, which is kind of nice. This first one on the left, the domain, if you think about the x's on your graph, this graph is going to continue forever. It's slowly heading to the right, but it will eventually go to the right and it'll reach every single positive x value. The left side of our parabola, heading to the left, will eventually reach over and over and over and hit every single possible negative x value. So our domain for the x's is going to be all real numbers. And this is our little symbol. I'm not sure if you guys have seen that before. It's like an R with that double line starting it out. So your domain is all real numbers because our graph will eventually hit every single x value. Now our range is going to be a little bit different. We can't say all real numbers for range because if you notice, we don't have any graph down here. Our graph starts here and goes everything above and everything above. So it will, if we put arrows on that, eventually hit every single x value, every single y value up here heading up to positive 10, 20, 30, a million. Same thing on the left side. That's going to hit every single y value up there. What our graph will never hit is this part down here. So what we say for our range is that the y's are all greater than or equal to, and then what value are they greater than or equal to right here? If you think in terms of y's, we went down 2, so greater than or equal to -2. All right, so next graph, domain. Now here's a nice little hint. Your domain for every single parabola is all real numbers because your graph will eventually hit every single x value that exists. Your range, however, will not always be all real numbers. This is where you have to look at the graph and say, where where does the graph start and which direction is it going. So it starts right here and everything is below that value. You don't have any graph up in this area. So because it's everything below, your y's are all less than or equal to, and then less than or equal to what value? Well, here's the highest point, and we care about the y's, so we went over 1 for the x, but we didn't go up or down at all, so it's less than or equal to 0. Your graph will start at 0 and hit every single y value smaller than that. All right, so last slide. When we graph these, we're going to start out with graphing them from a table of values, and then we'll get to kind of an easier way to do that, but we always have to start this way. This is a great question to look at before you even do your graph, because we know what to expect this graph to look like. Does it open up or down? Well, look at your a value, the number in front of x squared, because our a value is a positive 2. This graph is going to open up. If I end up with a graph that's opening down, that means I made some mistakes in my math over here. So it's a good thing, it's a good little checkpoint for you. All right, so I'm going to go ahead, I'm going to do one of these, and then I'll fill in the rest. So if you plug in a negative 2 for x, you have 2 times negative 2 squared minus 4. Make sure you simplify your exponents first before the multiplication. So negative 2 squared is a positive 4 times 2 minus 4. Then you would do the multiplication, 8 minus 4, which is 4. So we get the y value of 4. That kind of ties in with your domain and range. Our input, we just put in a negative 2 right here. And the output, what did you get back? Positive 4. All right, I'm going to pause this and just go ahead and fill in the rest of the values to save a little time. All right, so there's our values. We can go ahead and plot these points, starting with the origin. Negative 2, positive 4. It's going to put us right there. Maybe we'll make this, a little bigger. Erase that. Then we have negative 1, negative 2. Right there. 0, negative 4. 1, negative 2, and 2, positive 4. So as you guys do your graphs, you just want to make sure that you are graphing something that's forming that U shape, that parabola. All the points, or your graph as you graph it, should look symmetrical. I didn't quite get down low enough there for that one there, but we understand. If I had some point that wasn't in line with this parabola, I would know I made a mistake with some of the math up here. So domain, you guys remember what the domain is on every single quadratic function, all real numbers. And the range, we have to talk about the y's for the range. The y's, because this is opening up, and by the way, the graph opened up from the ordered pairs, which matches the fact that we knew it would open up. All right, the range, all the y's are greater than this spot right here, so we'll say greater than or equal to. And then what is the value of the y? Negative 4. And that's how we will graph a few of these.